Hello, good morning, afternoon, evening, and wherever you are in the world. Today's webinar is on the aerospace solutions and how HyperMILL can help and enhance your process. My name is Adrian Smith, and I'm MD of Oakline in the UK. I have a background in motorsport and aerospace structural machining. Today, my co-host is Nitin, who is also an MD from OpenMind India, and has a background in aerospace and rotational parts. Together, we will step through and show HyperMILL and how it can solve your problems and give you new direction and ideas in these challenging times. So over to you, Nitin, and we will start with the presentation.
Well, thank you, Adrian, and welcome everyone. Thank you for taking out time today to attend this webinar. During this webinar, I will be, as Adrian mentioned, covering the first half of this presentation on manufacturing of engine components, and then Adrian will follow up with the manufacturing of aerostructures. As we all know, HyperMILL is considered the benchmark for CAM systems for the aerospace industry. Before I start, a couple of housekeeping things. If you have any questions, please type in your questions into the chat box. And also as handouts, we have our HyperMILL Aerospace Solutions brochure that you can download right during this webinar as well. So let's get started. This is a very interesting topic, aero engine components manufacturing with HyperMILL. Let's first talk briefly about aero engines, the types and the major components that are involved. There are different types of aero engines, could be turboshafts, turbofan, turbojets, and up to even the most advanced technology like ramjets. Further, these engines are classified into large gas turbines or small gas turbines, again, depending upon the application. Could be both civil and defense purpose. The thing in common with these engines is they are made up of basically three major components: compressors, turbines, and the combustor. And the compressors could be an axial compressor that can have a rotor and a stator, or it could be a radial compressor in case of a small gas turbine where you have a so-called an impeller. Turbines can be made up of bliss, stator, rotor, or single blades that are mounted on a disc. Most of these, as we know, are mounted on shafts. There's couplings, auxiliary units, and of course, there's casings, rings, and housings for these compressor, combustor, and turbine. So with these basics, HyperMILL offers a very comprehensive and integrated solution for machining all such type of aero engine components. So like we said, whether these are impellers or these are bliss, engine rings, casings, and so forth, we have the most versatile solution that you can use to manufacture any of these components. Well, let's talk about some of the challenges that we see when we are manufacturing aero engine components. Aerospace manufacturing usually is considered a high mix and low volume production. So there is a lot of emphasis on safety, stability, and reliability of the processes while making sure that there is an improvement in the productivity. We need to make sure that the processes are repeatable. There is a need for superior surface finishes. There's a constant need to achieve the surface finish while keeping low machining time. So In all, there is a need for a perfect synergy between the machine tool, the CAM software, and the tooling. So ideally, everybody is striving for all materials, all applications with one machine, which we know that in an idealistic world, it's really not always possible. So there's a fine balance, you can say, has to be maintained between the cost factor, the quality, and the time to delivery. Also, there is a need to always machine these exotic materials like titanium and Inconel, because you need material that can withstand a lot of stresses and high temperatures. There are practical challenges like how to eliminate chatter and vibration during machining and finishing of thin walls. So effective tool utilization and controlling of machine movements is also required. So with all these challenges, HyperMILL offers a very comprehensive solution that consists of various modules. It's a modular package. So starting from a dedicated CAD for CAM, which is developed in-house by OpenMind Technologies. There's a complete machining solution from drilling to 2D, 3D, and 5-axis machining for not only just aero engines, but in general, all types of industry applications. But since we are talking about aero engines here, we are talking very specific to that. HyperMILL is very unique in the industry, where we offer a very specific solution for machining of turbo machinery components like impellers, bliss, and single blades. We also have a complete solution for machining, for complete turning solution that is available for machining of shafts, casings, rings, and housing. Along with that, we also offer a lot of technology when it comes to adaptive machining, automation, additive manufacturing, and also simulation and verification, what we call virtual machining simulation. And all these technology leads to Industry 4.0 initiative, or also what we call even the digital twin. Now let's talk more specifically in terms of all these various modules, starting with HyperCAD-S, which is a perfect CAD for CAM. It has things like feature-based recognition capabilities, even for turbo machinery components. So you can recognize various features that are in your impellers and bliss. The analysis function provides information on critical geometrical parts. So in case of impellers, functions are available to check whether the blade can be flank or pointment. So depending upon the surface, you can choose the strategies. There is a direct interface with various CAD systems, like to name the few, CATIA, SolidWorks, and Siemens, and so forth. So there is minimal or no data loss when you're importing these native files into HyperCAD-S. You can also make use of parametric modeling in HyperCAD-S for quickly making some on-the-fly geometrical changes while maintaining the parametrics of the model. For example, if you're changing the root design of a blade, it will still maintain all the parametrics. HyperCAD-S also offer PMI information, product for manufacturing information, which is very important for a CAM programmer to be able to make sure that to do his job well when he's programming these turbo machinery parts. Also, HyperMILL links to various PLM, product lifecycle management tools. So there is a all the information that you need to be sending to your PLM tools can be sent to these systems. Now let's talk about some characteristics of impellers and bliss, what we also call multi-blades. So usually turbo machinery components have some very unique features and characteristics. The aerodynamic performance of these components can be majorly affected even when there's a minor changes that are made to these components. So specifically for impellers and bliss, we have a minimum passage width with very thin and twisted blades. So depending upon the design, these blade surfaces can either be ruled or unruled. There's leading and trailing edge can be of, again, different types with varying radiuses, aspect ratios, and thicknesses. So you have to make sure that you're considering all these things when you are programming a part. And impellers and bliss can also be either shrouded or unshrouded. So based on it, you have to select the right strategies and the tools. And these components are, as we know, made up of a tough to machine material to withstand high stresses and temperature. So to make your life easy when it comes to programming for these so-called impellers and bliss, HyperMILL offers a multi-blade package. This is very specific for machining of impellers and bliss. Okay. So starting with their strategies for roughing, finishing of the blade, whether it can be point milled, flank milled, and finishing of fillets and hub. There is a lot of time savings is possible when using things like strategies like tangent milling feature for finishing of the blades that are point milled. Here's an example we're showing here, which is showing the finishing of the blade using barrel cutters on a bliss. And of course, this has is having a high depth of cut. So using a barrel cutter to finish this makes more sense in this case. So we offer very specific strategies as part of this package that are unique and can be applied for easy manufacturing, first programming, manufacturing of these impellers and blades. So what are some very specific advantages of these multi-blade packages? First of all, there's short programming time, machining time, and the superior surface finish that we want to achieve with the multi-blade cycles is very much possible. There's minimum steps that are required actually in CAM programming of these parts using this package. Roughing can be done with either general HyperMILL cycles as well as multi-blade cycles. Ruled surfaces can be checked using UV curves or zebra analysis, or even using multi-blade flank milling cycles that I showed you in the last slide. Flank milling gives a very uniform finish for the blade surfaces. There's effective feed rate control. It is possible to attain high quality leading and trailing edges. Blade numbers also have a major role to play for the passage width, as we know. So it is very important to find optimum tool path without collision with these blades, which actually HyperMILL can do automatically. So that's a huge help, part of 5-axis simultaneous machining. HyperMILL also assures perfect blending between the various sections for long and thin blades. So the tangential position is always maintained to provide better tool utilization. For finishing of hub and point milling of blades, there are special tools like the lollipop cutters that can be used for shroud-based, where you have an integrally shroud stator, so you can use that. Although aerodynamic performance has a major effect on leading edge and the Phillip Radius, these are usually quite concerning for manufacturing if they are not designed well. But with HyperMILL, it is very easy to program these edges using our multi-blade package. Now let me show you this short video that's showing you a few processes that are involved while machining a multi-blade component. Okay, starting from the CAD import, you can program for stop turning, probing, followed by roughing, semi-finishing, and finishing. Here the simulation shows a complete 5-axis machine with the fixture. Program generated actually is completely checked for collision with the fixture, machine spindle, and the bed. Also, the simulation that we are showing here is just our standard simulation. For the real NC code simulation and the optimization, we also have another tool available called virtual machining that we will talk maybe later in our presentation. And after machining of the component, on-the-job probing can also be done to measure and understand the deviations that may have occurred while machining. Now let's move on. We have talked about multi-blades. Let's talk about single blades. And again, single blades also have some unique characteristics that one needs to consider while machining them. Single blades are usually a set of aerofoils that are stacked together, with a specific twist angle. So they can be patterned to get the complete assembly, and this can be done in HyperCAD itself. So that makes it very easy to repair and replace these aerofoils that you have stacked together for getting the complete blade. Aerofoil design, leading and trailing edges, root radius at the hub, shroud areas, all these play a very important role in the aerodynamic performance of these blades. So one really needs to consider all these things, what we call design for manufacturing aspects when you are looking at design and manufacturing of these single blades. Most of the time, these single blades have complex fir trees and specific platform shapes, as you can see in the image that we're showing on the right bottom side of the screen. HyperMILL can actually map all these special tools using HyperMILL freeform geometry. So one can easily program all these various shapes of fir trees and root design that you're seeing there with contour milling with the special tools in HyperMILL. So it makes it really easy to do this. Also, turbine blades, as we know, like multi-blades, are made up of quite tough and exotic materials. And again, they need to withstand high temperature from the hot gases that are released from the combustion chamber. So with all these points in mind for a single blade, we have a very special package for machining of these single blades. There are special machining strategies that are available that can be also mixed with the general CAM strategies that is available in HyperMILL. There are strategies that are available for 4 and 5 axis roughing, point milling for the pressure side and the suction side, including the edges, as you can see with the various graphics that are showing here. Top milling of semi-surface of the blade surfaces is very easy to do with spiral toolpath. The platforms having ruled surface can be flank milled or they can be point milled. Even for single blades, we can use barrel cutters quite effectively when it comes to machining, finishing, and one of the animations that you're seeing here is showing that how easy it is to do that and innovative technology. Okay, so what are some very specific advantages of this single blade package that we have to offer? Single blades can get, with this package, you can do collision-free toolpath for all different axis toolpath. A realistic stock model recognition from the previous operation is very much possible. And this eliminates all the unwanted toolpath movements and also leads to reduction in machine time. Similar to multi-blades, roughing can be done with either general HyperMILL cycles as well as single blade special cycles that I showed you in my previous slide. Also, high performance roughing is available for chipping of the material faster. Rule surface can be also checked using a single blade flank milling option, where line contact must be maintained while passing of the tool. Top milling gives a very uniform finishing of these blade surfaces. Plus, there is possibility to control the feed rates and the RPM for finishing of the leading and trailing edge, which is quite important and challenging part of machining of these blades, as it can leave marks on those surfaces. Also, the last point, you can see it is possible to do a lot of automation with HyperMILL for machining of single blades, and we'll talk about that in later slides. And we'll also talk about adaptive machining of these blades as well in a separate slide. Okay, so in this slide, I'm playing a video. And again, this video is available on our YouTube channel as well. And this is showing a turbine blade that is being machined with the HyperMILL on a Grove machine with Mitsubishi tools. And the material type here is aluminum, or some parts of the world, aluminium. Single blades, as we know, have very thin profiles, so deflection is quite a common issue. But for HyperMILL, this issue can be very easily addressed. There's roughing that shows a high material removal rate, and to get to a near neck shape of the blade, as you can see in this video. So we're using this innovative barrel cutter technology. So as you can see here, roughing a segment for this blade, which is followed by even finishing using the bottom radius of the same blade. So we're using the same blade for roughing and the finishing here. And this segmental blade machining process provides stability to these thin blade structures. And of course, again, the same barrel tool is used for blending and transition towards the platform. So quite easy to machine even the roots and the fir tree with simultaneous machining as well. Okay, I'll just let it finish. And again, video is available for you to watch on our website as well, our YouTube channel. Now, let's also talk about adaptive manufacturing, and which is in particularly very useful when machining of these single blades. For free-form shapes, usually with complex geometries, the blades and vanes usually deform during the machining process, and adaptive manufacturing allows to find what we call the best fit, the best blade position after it is deformed, and that can be very quickly reprogrammed. So there is a automatic adjustment of the true position, which provides us the best fit position for the blade in relation to the root. So we are graphically here trying to show you an example how it is done. So there is on-machine probing for the blade position, original position. There is then automatically designing and blending of these surfaces for the real position that the software is doing for you automatically, and also recalculating and then generating the unique NC code for each blade as well. So this eliminates the need to do manual measurements by CMM. So it is all done automatically. So the advantages, there's a huge potential for time savings. Of course, there's a reduction in operating cost. It's more reliable. The cycle time gets reduced, and of course leads to better accuracy and quality, lower scrap as well. Okay, HyperMILL also offers, as I mentioned in the beginning, mill turn technology, which is again milling and turning in a single GUI. So nothing is separate. In the same GUI, you can do milling as well as turning. All the turning strategies like roughing, finishing, plunging, that involves groove roughing and finishing, thread cutting, drilling, they're all available. Okay. Also using high performance turning, trochoidal path can be generated very easily, as you can see in these animations on the right hand side. Even 3-axis simultaneous roughing and finishing utilizes the advantages, utilizes the complete tool, and gives a very, very flexible tool path orientation. And in our future releases, you will see we are going to merge these technologies as well. Also, HyperMILL offers some very innovative and effective turning process called roll feed. Okay, so this technology actually is very helpful for turning off tough material when it comes to using special tools, as you're seeing this in that bottom right hand image for different types of surfaces, grooves, and inclinations. So this is something very innovative technology that is available exclusively from HyperMILL. Okay, with that, I will now turn it back to my colleague Adrian, and Adrian is going to throw some light on manufacturing of aerostructure components. Adrian, back to you.
Okay, thank you, Nitin. Very informative. We're now going to hopefully pass it over to me, and we're going to take a look at component manufacturing. Let's start. Okay, so hopefully it's clear that HyperMILL is suitable for all components in the usual airframes that you could be dealing with. Certainly in the UK, we deal with a lot of wing structures. So you'll see a lot of rib work for assemblies in the UK. And so these parts are fairly typical what we find in the UK. Today, I want to focus on really the technical aspects of HyperMILL to show you how easy some of these things are to program inside HyperMILL. But first, we want to look at what makes up a structural part. What are the topics and the key features within those parts that we have to address? And we can see the usual process is that these parts take, they have a lot of roughing that needs to be removed. A lot of material needs to be removed from these parts. So roughing is one of the important topics because there are a lot of pockets in these components. These pockets are made up of intersected by ribs. And so these pockets could be short, they could be deep, they could be wide, they could be long. And so we need different techniques to machine those pockets. Those pockets are made up of ribs or walls, and those ribs also create a challenge. The walls, of course, can be cut with a swarf cutting, but there is a general trend where because of weight, these fillet radiuses are getting ever smaller. So how to machine those walls with very small radiuses, and as parts are merged together, the complexities of these parts are getting quite a challenge. So we'll take a look at some areas here how we can solve this. And also, certainly aluminium is a material very common in this industry. There are also a lot of other materials like titaniums or nickels that are also becoming more prevalent in the industry that need to be machined. And so we need different techniques for these materials as well. So today's part is a part which is, if you can see top left-hand corner, this is roughly 450 millimeters long. It was machined in 2.5 hours, and it was finished complete. So all deburring and operations ready to go. Very, very minimal cleanup to finish this part. So, of course, there are many areas in this part that can be or could be a challenge. But we're going to take it today six different areas which we feel HyperMILL can offer some advantages, or show you some different techniques where it could be useful. So let's start with the roughing. So the roughing is obviously, as I said earlier, the roughing is there's a lot of material to be removed from these parts. So different techniques for roughing, and I'm going to show you two different techniques here and briefly touch on how we can use them in different ways. But then I'm going to look at these what I call deep closed pockets. These are pockets which are difficult to get access into, usually in one direction, and how do we efficiently remove material in these pockets. The third topic is really what I call flat faces, or flat faces, difficult to reach faces, and these flat faces really could be slightly curved as well. So it's also a general trend in aerospace manufacturing that these parts have some curvature on there. They're not perfectly flat and planar. The fourth topic is the fillet radius. So as I said earlier, because of weight issues, these radiuses are getting ever smaller. So it is also always a challenge how to machine those. Of course, you can get longer and longer tools, but then the diameter is quite small. So this is really a challenge to machine these in an efficient way. So people often end up maybe scanning this with a ball mill type tool to get the job done. But we're going to take a look at how we can do these things. The next challenge is rib walls. So often I find people will say rough down to the top of these rib walls and then try and finish them because they are because the stop vibration, because they're supported and stable. But we're going to show a technique here where we can remove all the material very close to finish shape, and then come back and finish the rib wall tops without vibration or damage, and give a very high quality surface. And the last area, which is sometimes overlooked in part manufacturing is deburring. So if you want the part to come off finished, and just spend a couple of extra minutes on the machine so that there's much less bench work for someone to hand finish this this part, then deburring is also a nice topic to take a look at. So let's dive into roughing. What we're going to do here is go one by one in these sections, and then really dive into what we're doing, and then how do we achieve that in HyperMILL. So I said earlier that you know, roughing is important. There's a lot of material to remove, so it's a key point of machining this component efficiently. So it can be that the roughing is 95% or more of the actual volume of the component and billet. So this is an important topic to get done quickly. So how we would go about this, I think first of all, the first topic is to look at the work holding. So how can I hold this piece to have it stable, but to get best access into this part? So what we don't want to do is to have too many operational secondary operations and setups to machine this part. So we're trying to machine this part as best we can in one setup. So step two is how we remove that material in an efficient way. So I call it how you slab off this material. So it's you know, the use of 5-axis machine tools now enables you to orientate the part to a nice orientation or suitable orientation, where you can then machine with a large diameter tool with many cutting edges in there to best balance your power that you have in your spindle against what's possible. So you're trying to utilize the maximum out of your machine tool to get the most material off that part as quick as possible. Yeah, so these obviously these if you look at other materials, titaniums and stuff, they're obviously using different techniques here to best give you tool life in these operations. The worst thing that can happen really is that you need multiple tools to machine a part. So different techniques, maybe larger tools and more cutting edges, or using completely different technique to machine these operations. So we have 2 videos running here, and I think the first thing to say is that the top video is using max machining cycle. This is using a technology where you're engaging the maximum amount at the flute length, so a very high Z step down and a smaller step over. So typically in aluminium, this can be 50% or so with of diameter. So this is using the full cutting flute of the tool and giving you quite a nice result. This is very nice for machines which have limited spindle, or in this case, the fixturing is not great because it's not as stable as it could be. So this is a nice way of removing material and keeping stability in the part. The second video below, this is using our perfect pocketing technology. So whilst the first one does a very nice result, there is actually a lot of repositioning moves. And so with aluminium, which is a little bit forgiving, you can do more. Okay, so with perfect pocket technology, what we're trying to do is to pattern fit shapes inside this toolpath, and so we're allowing the machine to try and move in a straight line, so it can actually get up to the program feed rates. So this is a nice result if you really want to push and explore the limits of what's possible in machining with aluminium. So back to max machining. So you can see this max roughing cycle is using a trapezoidal type toolpath. So it starts on the outside and it's peeling into the pocket. So at every cut is repositioning. What's nice is that we're adapting the feed rate. So as you come in on the part, the feed rate optimal for whatever position it is in that feed rate. So you're not actually using the worst or adjusting the feed rate because of the worst case conditions. You're adapting as the tool is moving throughout the part. So as I said before, really nice on parts where maybe slightly limited spindle, or it could be that it's a difficult hard material that you need to cut, or the fixturing or the part setup is not optimal. So nice result, and it's gained quite a bit of traction over the last few years. But I would say it's not the quickest way of cutting aluminium, and that's what we're going to look at in the next result. But it definitely has a purpose, and gives you a very nice result. As you can see, what has been a trend in the past is to make a roughing cycle, a roughing toolpath. And the way this is done is, if you can imagine, we're looking at toolpath now in this picture on the bottom right, where you take a section through the part, and then you offset that section by the tool radius or the step over. So you make a number of step over passes, and then you link these together. So certainly with these connection macros and how it connects from one toolpath to the other, this is not so great for hard materials because it puts forces into these areas where it's not as stable as it could be. So with perfect pocket technology, what we're trying to do is pattern fit shapes inside this pocket. So what we're doing here is we're making a rectangle, we're placing a rectangle, but within that rectangle you can see it's a spiral. So we're spiraling that toolpath, making a toolpath spiraling out to almost the last toolpath, and then we fit to the actual shape of the component. So wherever possible, we're getting the machine to work in a straight line where it's able to achieve the program feed rate. And if it is aluminium, usually the limitation is what how quick the machine can accelerate and decelerate. So this is putting the machine in the best possible way to get the programmed feed rates. The second topic I want to look at is these closed pockets. So this is a technique where we're programming helical movement into the part. The tool is slightly leaning forward, so no need for pre-drilling. This is, you can go straight into the component. The nice thing here is that, of course, you punch a hole into this pocket with some sort of U-drill or drill type approach, but this is usually quite high forces on the machine tool. So with these setups, this is quite a nice stable process. The big advantage is that you don't need a high tool count. So if you have lots of different size holes in this component, you don't need lots of different size tooling. This one tool will give you multiple depths and hole sizes. So it does dramatically reduce your tool count on your machine, so you can keep it free for other tooling. The best results are really made with more difficult materials. So the more difficult the material, the harder the material, the better the result and the difference you will get compared to normal type approach to machine that hole out. And of course, you can see the way it's working. You have a natural swarf evacuation type. It's being thrown out of the pocket, and the chips that are made are very small and nice, can be nicely handled by the chip conveyor of the machine tool. So it's a nice stable process for production. How to machine this? This is now our first look into HyperMILL really, and you can see here it's as easy as drilling. So we're going to pick a tool. This is our tool, but we have different profiles depending on how we use this tool. So I'm going to choose a different profile, which gives you different speeds and feeds. I'm going to select the center line on that pocket, and I'm going to give it a diameter, in this case, 75 millimeters. Just showing you some options. We have lots of different options here that we don't need to touch. We can adjust if you want to, but you can see, pick a tool, pick the pocket parameters and calculate. You can see now HyperMILL is taking care of whether it needs Or you can do the whole thing in one spiral toolpath and then step out, or it needs to go halfway down and then step out and then goes into the second part of the whole feature. So HyperMILL is splitting up the toolpath based on the collision characteristics of this pocket and the size of tooling. So it's really simple to program. It takes a lot of the hassle of trying to get a nice result with your CAM system. So nice, easy way to produce and take material out of pockets. The third topic is really flat faces, and I think this point really is open mind speciality. Certainly, these faces now are becoming a little bit curved, or indeed they could be flat, but the real problem is that they're very difficult to access. So if the pocket is deep, and I think this pocket is something like 160 millimeters deep with a 4 millimeter rad on. So the tool needed, if you were going to do it conventionally in a sort of 3-axis approach or a swarf cutting approach, means that a very long tool with a very small radius, which is like the dream fantasy tool that you can program in a CAM system, but in reality would never work on it in machining. So here we use a completely different process, which is this tool, which we'll look at a little bit more in detail in a second, is a barrel tool. So this barrel tool is made up of a radius between 300 and maybe 1.5 meters in diameter, and it's put on a taper, which I'll show you a second. With that taper or on that tool is the important point that we want to look at in a minute. Very high time savings are achievable compared to, let's say, scanning, which is what most people are doing if the face is slightly curved. So video shows far left hand video. You see the barrel tool here. This is quite a large radius, and you can see it moving in this pocket, and you can see it's using a simultaneous motion to get right into the corner. So as it comes across the face, it pendulums so that we're getting the tool right into that corner. If you don't do this, then obviously you are left with a very big wedge of material that's difficult to remove later. So this simultaneous motion is important. We then have a cleanup blending pass that goes around the outside to finish the tool path off and to take out the small cusps. But this is a very dynamic motion on the part. So you can see here what it's doing now in the far left-hand picture is that it's actually indexed. So it's a 3+2 operation. So this is really nice toolpath for gantry style machines that aren't so dynamic. Okay, so this is a really nice result for these type of machines, and the two toolpaths have a special blending macro between them to give you, so you can't see the witness or feel the witness arc between these two toolpaths. If you compare the left-hand video to the right-hand video, you can see cutting this face with a barrel tool gives a result in something like 35 seconds. Whereas if you did it with a conventional ball mill, this is 11 minutes. So there's a considerable time saving cutting these type of features on a part. So where can this be used? Well, it can be used on, as I said, flat faces, on slight curved faces, so wall machining, but you can also use it on the bottom of these pockets as well. So if the taper is quite high, then you can use it for these bottom machining as well. The taper is key. The taper moves the tool naturally out of the way of collision. So a barrel tool is not the same as a conical barrel tool, and so people should really look at the difference, because this conical barrel tool is the key to successfully machining these type of pockets. Excuse me. Okay. Slight lag here. Okay, so let's see how this works in HyperMILL. And you can see what we're going to do here, which I think is really important, is to show you how we can build this tool parametrically. So this is not some sort of cheat with a large ball mill or something. This is a real tool being designed and parametrically driven in HyperMILL. You can see we're adding now a tool holder as well from a library, and we're pushing these two units together to form an actual cutting assembly. So once we have the tool, we're going to interface with the CAD system. So we're not actually locked within the CAD or the CAM. We're using some CAD functionalities to pick this face and machine. So you can see really tool, pick the face, calculate. HyperMILL is really taking care of everything else in that sequence. So yes, you have a lot of opportunity for adjustment, but it gives you a result straight away. So you can see here, I've copied the cycle, change the result to the corner machining, and you can see here we have a toolpath to take out the corners. So because the cutting conditions are differently, you can do that in the same cycle, or in this case, I've copied it, and you can play with the offsets because the cutting conditions are different. So real flexibility in machining this. Another area is small fillet machining. So you can see here we are machining up and down this fillet radius. You can see that rather than using the normal Z level type cutting strategy where half the cut is in air, this toolpath is going up and down the fillet radius and gives you an ability to get a nice step over without making lots of terraces in the more conventional way of machining. So it's a very stable process. It's a 3+2 positioning. Very short tools are possible. So definitely because of the small tool length, you can push the technology values quite high, and so will give you a really nice surface finish and a very high quality surface and a great result. So this can be used in both a roughing process or a finishing process. So the roughing, if you've gone in and taken this pocket out, as you can probably just about see in this toolpath with a nice big diameter tip tool, obviously there's a lot of material in the corners to remove. So you can use this technique to remove this material very quickly from the corners. You can then use this process again to finish in these corners. So you can get very good conditions in the corner. So let's see how easy it is to program this. And then here I'm going to pick the cycle. We're going to pick our tooling from a library. So we have a bunch of tools loaded. So we're just going to define the tool that was used before in the roughing operation. Now we're going to pick our feature or fillet that we want to machine. Is what we've done. And you can see the CAD there is extended all the features, all the faces larger, so it doesn't roll over. So this is done automatically, nothing for you to do. So you pick the toolpath, you calculate, and then you can see a very quick result. So you can see the up and down machining. As we get to the bottom of the pocket, we've got a different approach to get right in the corner, and we can even machine the base of this pocket to give you a toolpath that cleans up the base where the bigger tool couldn't get right into the corner. So this is almost like a 3-in-1 cycle. Very simple to use, very powerful, very easy, very flexible. This, I think, is really a unique type of machining process in the industry currently. So this can definitely give you big results if you wanted to achieve the good cycle times. Next topic is rib walls. We're using this barrel tool technology again. This barrel, because we have this taper pushes the tool away from these collision problems you have with the part. And you can see here, we're actually machining the top of the rib walls. The forces or the cutting forces of the tool are being pushed into the rib rather than against the rib. So you don't get this vibration or noise that comes out with if you cut in more conventional end mill type process. The surface that you get on it is really high quality. Okay, and the nice thing is the different orientations that you have between those different ribs, because of the big radius of the tool, the blending between them is really a great result. So it does really hide maybe some inaccuracies that you might have on your machine tool, because of the radius, with this radius diameter, it's hiding that a little bit. So the blending as you go from in different orientations and different faces, if you really look at it in detail, is perfect. Okay, so it's a really nice process. No noise on the machine, high quality, very quick process. So it enables you to really rough the component out in full, and then deal with the rib walls later. So it makes the programming sequence much easier for the programmer. Just get the material down and finish the rib walls. And conventionally, you would have to do the roughing in several steps to support the top of the rib, so that you can machine it successfully. How do we do this? Really simple. Pick the cycle, pick a tool. Now we're going to pick some radiuses. So we're going to interact and use a chain command, which is really nice. So we've just chained tangentially these edges, and I don't want this one here, so I'm just deselecting it. So we got it loaded. I'm then going to load another curve in at the same time. Good, we've got two. Now I'm going to tangentially select the surfaces that I want to run against. So this gives me the 5-axis orientation. Production mode, of course, because we want to cut down the amount of time in air. And then it's Toolpath. So super simple, easy to use. And if we look at the simulation on this Toolpath, then you can see we've got a really great result in machining this wall. So super easy, powerful, easy to do. The CAD interaction of picking those edges and surfaces are really nice. So some parts are not so nice for you, and you have to go along and make multiple selections with the chaining and the functions in the CAD and the selection process. Really easy, quick to do. Just a few clicks and you get a good result. The last section is deburring. And you can see here now we are going to be deburring this part. So the nice thing, I guess, is there's no one fit toolpath for all these different areas that we want to machine. So having a nice linking motion between all these different little cuts, which is safe, is a really nice process. It's very, very quick, to just a few minutes, and this part is finished deburred. So you've got a little break edge putting on this part here, and it just wanders around, and after a minute or two, it's done. Finished, consistent. So no deviation between operators, let's say. It's done on the machine, just a few minutes. So you can let the operators be doing something else rather than benching these parts to finish them off. So again, just a video, you can see a number of different ways we can machine these different results. We can do it in 3-axis, we can do it in 3+2 indexing, we can do it in 5-axis simultaneous, and then we can link them all together. So it's a small programming effort really, but a really large return on quality. It's really what we'll say is a consistent process and nice result. All this movement though needs to be handled, and this is a first look at for you for a virtual machine. And virtual machine here is really giving you the confidence to get this part on the machine. It's an NC file verification tool, simulation tool. So you can see this is running in a NC file, not an internal language. So we're taking care of all the linking, reposition moves. Everything is handled in the virtual machine. So this is a big growth area for OpenMind, certainly with Industry 4.0. It does offer huge benefits in your shop to get a reliable process on the machine tool. So thank you for my part of the presentation. I'll hand back over to Nitin now, who will finish off. Thank you.
Well, thank you, Adrian. That was a very interesting presentation and never fails to amaze me every time I see it, all that technology. Okay, let's quickly talk about a few innovative technologies that HyperMILL has to offer. And we are all hearing the word automation from different parts of the world. Automation means different things to different people. But yes, we can truly automate CAM as well with HyperMILL. So HyperMILL offers some basic CAM automation, which is out of the box functionality for every license of HyperMILL. And then we also offer advanced automation that can do complete CAM process automation, starting from CAD importing, analysis of the CAD files, fixture loading, alignments, feature recognition, programming, simulation, and finally NC code generation with few clicks. And yes, that is advanced automation and needs some help from our side. So a family of parts and complex machining process, usually require a lot of programming time. And with this automation, you can reduce all that programming time. You can reduce manual intervention. That means less errors. And also, this means able to use less manpower when it comes to doing programming. So we also have feature recognition. So even for aero components like impellers, it works as well. So you can even use for recognition of holes, slots, pockets, and even with our multi-plate package, there is simple feature recognition interface that is available, and that is what is shown on the right side on my screen with that image. There are macros that one can write, which allows definitions of rules and various conditions for each machining steps, and then programming can be done with a few clicks. We also have something called CPFs, customized process features, for a collection of specific machining events, relevant information from your CAD model. Like you can use various entities like colors, names, shapes, and so forth. And this allows definition of special standards or your customized standards that you may have in your organization related to geometries, and you can further automate the programming based on these CPFs. So yes, it can truly automate your complete CAM program. Also, let's talk about additive manufacturing, hot subject everywhere. Everybody wants to know about additive manufacturing. HyperMILL also has a module for doing additive manufacturing. We support basically two types of technologies, direct energy deposition, DED, and also power bed fusion, which is also called PBF. And for both these methods, there are various strategies that are available. And of course, a complete collision check is carried out for all the components that is involved in this. We offer hybrid manufacturing, which is a combination of additive and subtractive manufacturing. So you're seeing these various videos at the bottom. related to aero engine components from left to right. You can see there is a propeller that is we're adding the blades by additive technology. In the middle, there's a single blade where we have added Inconel just on the leading edges where you really need Inconel and you don't need to have a complete blade. And on the right hand side, we are seeing an engine nozzle that is being additively manufactured. So with additive technology, especially for aero engines, there's an opportunity to produce hollow blades, which has its own advantages. People who are into blade manufacturing, of course, they are lighter, but at the same time, with the same aerodynamics properties you can have. Additive also helps you to for tooling repair, for preparing fixturing for complex shapes. Very useful technology when it comes to MRO kind of business, where you need to repair engine parts, okay, refurbishing and upgrading your aerospace components. So, yeah, I mean, we have a very good solution which allows you to, even with 5-axis simultaneous process, where complex shapes can be manufactured even without adding of supports, and where you are doing additive manufacturing with the support structure. HyperMILL can help you to remove those support structure as well as finishing of those components that have been purely additively manufactured as well. Finally, we also have some very unique technology, what we call 6-axis simultaneous knife cutting. So as we know, composites are very important in aerospace industry, especially aerostructures, like we are showing this in the wings. As for their structural benefits, they are lightweight, they're stable, durable, and so forth, and also offers good insulation. So HyperMILL offers this technology called the ultrasonic knife cutting or 6-axis simultaneous machining, and you can see in this video on your right hand side for cutting of these honeycomb structures and fiber optical material and even carbon fiber material, a lot of it used in aerospace and also a lot of automotive industry and even foams. So you can use this. So, and this is a complete CAM solution, for ultrasonic cutting with oscillating tangential cutting blades. So this is in combination with our proven milling strategies. So you get the best of both the worlds, advantages of our technology blended with this innovative technology in a single user interface. So the 6-axis movements with automatic tool alignment here gives a very clean and smooth cuts. And this technology has special finishing functionalities as well, as you can see in this video that we are showing. And this is with our partners, Harshman. Enjoy. Okay. With that, we have come to end of our today's presentation. We will keep this webinar open for maybe for a few minutes, because we are already, I think, over time by 10 minutes. Things to cover. If you need more information, it's available on our website. If you need very specific information, you can also email us on info@openmind-tech.com. Also, our next webinar in September is very specifically on additive manufacturing. It will be a very interesting topic. So please sign up when you get the invite. And you can also watch past webinar recordings from Open Mind on our website. There's a link that is given there. With that, we will open up for some questions, and I will go in there and check questions we may have. Okay.
Yes, there's one here. It says are three-axis turning, high performance and roll feed turning additional licenses to standard tooling? Do you want to answer that one, or shall I?
Maybe if you want to answer it, I'm still trying to see where I can find all the questions.
Yeah. Okay. So yes, that is an additional license. Specifically, definitely you'll need a slightly different tune post processor to be able to handle that three-axis movement. So there's some service work. If you have a need, I think it's Richard who asked the question. If you have a need for this technology, please get in touch with your Open Mind representative, and we'll be able to give you much more details and take a look at the licensing that you have currently to handle that topic. Hopefully that answers your question. But okay, there was one other question, which was which process do you think would really generate the most time saving in component machining? And I think that would, if I like that, probably easier for me to answer. And I think probably that is, yeah, I think maybe the finishing is definitely finishing with barrel tools is a real change in the landscape of what's possible in component manufacturing. It really is let's say a get out of jail card really for component machining in difficult areas, and rather than using very long tools, very slender long tools, which you get about either a bad surface quality, or you get tool breakage or problems with the barrel tool concept of being able to use it in 5-axis gives you a really nice option to solve these problem areas. So definitely finishing, compared to just using a standard ball mill, you'll get this 90% time saving realistically when you come to machining.
Okay.
Well,
thank you for answering these questions, Adrian. And again, if you have more questions, please write to us or contact your local HyperMILL representative in your region, and we'll be happy to answer your specific questions as well. Once again, thank you very much for your time, for listening to this webinar. And depending upon which part of the world you are, please take care, be safe and healthy. Thank you from my side. Adrian?
Yeah, thank you from my side as well. Hopefully we will meet again soon when the challenging times are over. Okay, thank you.
Thank you. Bye. We're going to close this webinar. Thank you.